Anjali Dikshit, and welcome to my lecture series, which is mainly based on seismic interpretation and inversion. Uh, and this is the first introductory session. So, this whole lecture series is a part of PMRF teachings delivered by me, a PMRF fellow in the Department of Earth Sciences, IIT Kanpur, India. So before discussing much, I first would like to introduce myself. So here is my brief introduction. So if I talk about my research, so I'm mainly interested in applying the state-of-the-art techniques such as a deep neural network for seismic interpretation and pore pressure prediction. And so I've categorized this whole research into three major categories. First is the seismic multi-attribute analysis using neural networks. Second is application of machine learning in seismic. And the third one is the global optimization algorithms. So before coming into this research field, I've did my bachelor's from UPS Dehradun, and later on I did the Masters of Technology from IIT Kanpur, and now I'm pursuing my PhD from IIT Kanpur itself. So during this education, I've got the opportunity to work in industry, both in both respect, like as a intern and as a employee, full-time employee. So during internship, I worked with Schlumberger, Kane India, and DGH, Directorate General of Hydrocarbon. And after my BTech, I have joined one MNC, which is a CGI, and I worked there for around 2.5 years. So next, let's talk about my research topic, which I'll be doing during my PhD work, is based on applying deep learning approach for seismic impedance inversion and multivariate pore pressure prediction. So now one can ask that what are the major implications or how your research work is going to benefit the industry or the scientific community. So majorly what I believe that this research work hopefully will help in estimating the more accurate pore pressure distribution at regional scale. So it will help us to understand the basin level changes in pore pressure. Second, if we have a accurate pore pressure prediction beforehand, then we can mitigate some serious hazards such as the blowout, and few of them are pressure cake, fluid influx, and some geological event as well, like mud volcanoes, submarine landslide, etc. And to avoid this life threatening hazard that I mentioned is blowout, so this pore pressure will help to plan a safe and economical mud window. So during this thesis work, my thesis supervisor are Professor Animesh Mandal, which is the professor in my department, that is Department of Earth Sciences at IIT Kanpur, and my other co-supervisor is Dr. Shiv Shankar Ganguly, who is a research scientist in the Deep Seismic Group at NGRI Hyderabad. Now let's understand that how this lecture series will go, and or what is the framework of this lecture series. Excuse me. So in this, so I've divided this lecture series into two major modules, where you can see that module 1 will consist of the in developing the theoretical understanding in the field of seismic, and the second module is more like application part, where we'll apply and understand the seismic data or well log data using Python or machine learning tool, which are the open source tools. So that's the best advantage that you can get in applying the Python, because it's freely available and it has a lots of library which will which can deliver the better and better results. So, in the theoretical understanding part, I first will give a brief about the what is the seismic method, then seismic inversion, what are the techniques involved in seismic inversion, and then the role of machine learning in the seismic inversion field. So, this is the broader workflow that I've designed so far, and definitely in later on time, I will add more and more content into that, and will add more topics like related. At present, I can see that I have missed the pore pressure part. So once I'll complete this seismic inversion section, then we'll move to the pore pressure part. So thank you all for listening me. And in the second lecture, I will discuss about the basics of seismic methods. So meanwhile, have a great day.